Good day, fellow. Today I just want to show you on how to prove for square identity. We have two of them, the square identity and also the quotient identity. But let me start with square identity. This one, I know you know this. Sine squared theta plus cos squared theta equals to 1. You see, we need to prove that sine squared theta cos squared theta is equals to 1. You see, somehow we are going to need a diagram. See, let's say if now we consider this diagram, this a right angle triangle with an angle of theta. Let us write our adjacent to be x, our opposite to be y, and our hypotenuse to be r, like this. You see, now we are going to consider the left hand side. The left hand side is sine squared theta plus cos squared, like this. Then we know that our right hand side is, or let me just say it's equals to 1, like this. Then from here we know also from SOHCAHTOA that sine is opposite over hypotenuse. Then we are going to write sine in terms of x, y, and r. Going to be sine opposite, which is y, divided by r. We close the bracket and we put squared. See, plus x, sorry, our cos is going to be adjacent, which is x is, and our hypotenuse, which is r. Let us write x over r, close like this, square. And now you can just distribute squared throughout. It's going to be y squared all over r squared plus x squared all over r squared, like this. You see, it's so simple. Then let me take you back to the fractions. Let's say if I had a fraction like this, let me write 3 all over 2. Then they want us to figure out or to simplify this given fraction. How would you do it? You will keep 2. Why 2? Because our denominator, which is 2 in this case, is the same. Then we then gonna add the numerator. You see, then at this point you can say then now 4 divided by 2, which is gonna be 2. See, same principle we are going to apply it here. We have the same denominator, which is r squared. Let us keep it. Going to be r squared, like this. Then we add our numerator, which is y squared plus x squared, like this. You see, I don't have much space. I'm going to write somewhere here. See, we have y squared plus x squared all over r squared. You see, then let us check carefully on this diagram. We have a right angle triangle, you see, and we know that we can also represent r in a form of r squared x squared plus y squared. Why do we say so? Because this angle is a right angle triangle. Then it is applicable for us to use the theorem of Pythagoras. You see, then you can just say the theorem of Pythagoras. See, we also have this property. We call it a commutative property. It's like if I have A plus B, I can write this in a form of B plus A. You see, this y squared plus x squared is the same as x squared plus y squared. You see, then we have r squared. Where you see your x squared plus y squared, you can then substitute with what? With r. X squared plus 1 squared is equals to r squared. Let us replace this with r. Then it's going to be r squared all over r squared, which is 1. You see, our right hand side is 1. Our left hand side was sine squared theta, cos squared theta. Then at this point, you can say now our left hand side is equals to the right hand side. You see, just like this, we have managed to solve the square identity. Now, let us try the quotient identity. Let me just erase this. I won't take long. This. Okay. This. I don't want to erase this diagram. Let me keep it. Now the quotient is this one. Tan theta is equals sine theta divided by cos theta. The quotient identity is this one, you see. Then we can then isolate tan to be tan theta, then also isolate. Okay, let me write it somewhere so that I could have more space. See, let us erase this one. We have sine theta divided by cos theta, like this. You see, using this diagram is so simple. For this one, we just say our opposite. We know again from SOHCAHTOA. Let me take you back. SOHCAHTOA, that tan is opposite over A, which is adjacent. Opposite is y, our adjacent is x. We're done with this one. Then, as for this one, I'm going to write it like this, because it will be much easy for us to visualize it. Cos sine theta divided by cos theta. You see, we know that sine is opposite over hypotenuse. Our opposite is y, hypotenuse gonna be r. We write y all over r. Divide our cos, which is x, divided by r. See, I want to simplify this further. What I'm going to do is I'm going to multiply, then this will swap like this, r all over x. You see, what is going to happen with r and r? They are going to cancel. Then I'm going to be left with what? With y all over x, like this. Check our left hand side, check on our right hand side. You see, we have the same answer. We can then conclude, I don't have much space, by saying the left hand side is equals to the right hand side. You see, it's so simple. The square identity and also the quotient identity. I just wanted to show you on how to solve for each. Thank you.